In this sixth episode on fractions, we're going to look at the operation of multiplication, and we're going to start off simply with a common fraction, 14 over 25 times 15 over 28. So any multiplication on any types of fractions has to be reduced to this form before you can start the method, which is called cross-cancellation or cross-multiplication. And I've especially drawn the times sign like that to show you that we're actually going to be looking at a denominator and a numerator, or a denominator and a numerator like that. The only way that we can use this cross-cancellation is if we use a number from the numerator and a number from the denominator. If the fractions are given to you as mixed numbers, in some examples we're going to do just now, you'll see that we have to convert them first of all to improper fractions, because both fractions have to be in the form of something over something times something over something. And what we're going to do now is let's first look at this diagonal here, which is a denominator and a numerator. Is there any number that could divide exactly into 25 and into 15? Well, they both belong to the 5 times table, so obviously 5 can go into 15 3 times, and 5 can go into 25 5 times. Once we've done that, we look at the other diagonal. So we've got a 14 and a 28. So you're probably all realizing straight away that belongs to the 7 times table. So if I divide 14 by 7, I'm left with 2. And if I divide 28 by 7, I'm left with 4. Now actually 14 can go exactly into 28. But I wanted to show you what happens if you don't think of the highest common factor straight away. What's going to happen then is, if you look at your two leftover numbers, your 2 and your 4, they are also going to be divisible by something. And because they're both from the 2 times table, we can divide them by 2. So 2 goes into 2 once, and 2 goes into 4 twice. When I think that I've cancelled everything that is available, I need to double check. Well, definitely dividing by 1 won't help. 5 and 3 don't belong to the same times table. I can even check like this, because this is also looking at a numerator and a denominator, but they also won't cancel. So when I get to that stage, I just need to tidy up, and I'm going to tidy up my numerator by saying 1 times 3 is 3, and tidy up my denominator. 5 times 2 is 10. And 3 over 10 is a common fraction. There's nothing that can be divided into both of them, so it's in its simplest form, and therefore that is your final solution. Let's have a look at another pair of common fractions. 3 over 7 times 5 over 8. Right, so if we start looking diagonally, we're looking at the 3 in the numerator, the 8 in the denominator. They definitely don't belong to the same times table. There's nothing that will divide into both of them exactly. So let's look the other way. 7 and 5, nothing will go into either of them. It has to be the same number going into the denominator and into the numerator, and there is no number. So if that happens, there's no reason to panic. It just means there is nothing in those two fractions that you can cancel. So you go straight to the tidy up stage, and your numerator says 3 times 5 is 15, and your denominator says 7 times 8 is 56. That may look like quite a messy fraction, but because nothing can divide into either of them, it is in its simplest form, and that's your final answer. So let's go on now and have a look at what happens if we have a mixed number, 4 and 2/5 multiplied by 2 and a half. So as I said over here, you cannot use the cross multiplication until you have a numerator over a denominator times a numerator over a denominator, and we definitely don't have that configuration here. But from previous videos, you'll remember that we can convert a mixed number into an improper fraction. So we're going to say 5 times 4 is 20. 20 plus 2 is 22 over 5 times 2 times 2 is 4 plus 1 is 5 over 2. So now that I've got it into that form, I can start trying to cross cancel. Well, glaring at me, there's a 5 here and a 5 there, so definitely we can say 5 goes into itself once and 5 goes into itself once. Looking at these two, they're both even numbers, so we can divide by 2. 2 into itself goes once, 2 into 22 goes 11 times. Nothing else will cancel. And just by the way, if ever you get to a situation like this where both of your denominators are ones, you know that nothing else is going to cancel. So tidying up the numerator, 11 times 1 is 11, and 1 times 1 is 1 in the denominator. Now remembering that 11 over 1 actually means 11 divided by 1. 11 divided by 1 is 11. You can also just remember that as soon as you get an answer where 1 is the denominator, you can actually just rewrite it as the numerator. And I would always suggest to do this to show that you do understand that anything over 1 is just itself. We can even multiply 3 mixed numbers or 3 fractions together. So let's have a look at that. Let's start with 2 1/4 times 1 1/3. So I've got a mixed number times a mixed number, and now I'm just going to throw in a common fraction. So I do have to go through the step of converting these to improper fractions. Of course, nothing can be done to that, so I'll just be rewriting that one as it is. 4 times 2 is 8, plus 1 is 9 over 4. 3 times 1 is 3, plus 1 is 4 over 3. And the common fraction stays as it was. So again, things will jump out at you straight away. You'll see those two 4s. You'll see that those two belong to the 3 times table. Then if you look over here, you'll see that that and that also belong to the 3 times table. So is there a correct place to start cancelling? No, not at all. You can start anywhere you want, and as long as you don't make any careless mistakes, you're going to get the same answer whichever order you cancel in. So just to prove to you that I can use a numerator here and a denominator right over there, and remember I could be multiplying by a whole lot of fractions, as long as it's in the numerator and in the denominator. So I'm going to divide by 3. 3 goes into 9 3 times, and 3 goes into 15 5 times. Right, let's go to this obvious one. 4 goes into itself once, 4 goes into itself once. Now I created a 3 over there when I divided 9 by 3. And remember, just like what happened up here, you can then use those numbers as well. So 3 goes into itself once, and 3 goes into itself once. Right, so look through. The only things left are here, but they are numerator and denominator, so let's just check them. Is there anything that can divide into these two exactly? No. So tidying up, obviously when we're multiplying by ones, it doesn't make any difference. But anyway, we've got 1 times 1 times 7, which is going to give us 7. There, everything's ones except the 5, so let's put the 5 down. And now, because the question's been given to you with mixed numbers, if it's an improper fraction, which it is in this case, give the answer back as a mixed number. So again, remember this means 7 divided by 5. How many times does 5 go into 7? Once. How many remain over? 2 over the same denominator. And that is how easy multiplication of fractions can be.